Welcome everybody to my presentation about microservices and monolith and how this is an annoying discussion. Thanks for joining. And first of all, concerning questions, if you do have any questions, feel free to ask them in the chat. We will probably also have a Q&A session later on where you can ask the questions in person via video and audio. But if you ask them in the chat, I might be able to answer them during the presentation. Let me introduce myself. So my name is Eberhard Wolff. I'm with InnoQ. We are a consulting company. We do mostly software projects. I'm sort of an exception. So I mostly do architecture reviews, trainings, consulting, these kinds of things. So I'm not really doing coding these days. And I have actually written a few books about microservices and technologies for microservices. And the sort of reason why I'm giving this presentation is because nowadays, a lot of people say, well, you know, microservices are just a mess. If you do a microservices architecture, it's just juggling too many small microservices. They are too small. It's all too complicated. And this is not the way that we should architect software. It's obviously wrong. We shouldn't start doing microservices. It's such an overhead and it's so very complex and we can't really get anything done. And they turn to alternatives, and the alternative is, of course, a monolith. And the reasoning behind that is that monoliths are obviously easier to handle because it's just one that you have, and it's not a distributed system, and it's all in one place. So it's much, much easier to work with this. And they are also much simpler. So it is a very simple architecture, and actually they look magnificent. It's a huge system, and they just looks very clear and impressive. And this is a picture of a monolith. So this is the monolith at the National Mall in Washington, DC. And I would agree that this actually looks like a magnificent architecture and like something that you want to have in your application too. So it's a good way to structure your system probably. However, thinking, as you can probably see, I do have some experience, and I can recall the first larger project that I did, and that was actually a deployment monolith. So by that time, there was no microservices hype, and we were pretty much free to do whatever we liked or whatever the team liked, and we did a deployment monolith. And the compilation time for that monolith, so it's like 15, 20 years ago, I don't really recall it, but I think it was an hour or probably even several hours. Starting up the whole system took about 50 minutes or so. It was an application server that was used there. So it was a quite complex system, as you can see. We had an integration with a lot of other systems, which made a lot of things hard. It was hard to deploy it. It was hard to test it because we had all the integration with all the other systems. And the deployment actually took 2 days. So when we did the initial deployment, we used a weekend because during the weekend, there wasn't too much traffic on that system. And we deployed that first release during those 2 days. And it was an exciting experience because at one point, there is this point of no return where you can't go back to the old system and where you have to release the new system. And it's exciting, but not in a good way. It's exciting in a rather bad way. And I wasn't actually sure about the commercial impact because at the end of the day, it was just a legacy migration. So I think that what we actually did is we just ensured that the new system was better maintainable. And fun thing, this system is now considered legacy and will be replaced soon by something different. Now you could say, well, you know, why do you tell me anything about a project that is like 15 or 20 years ago? Well, there are other projects. So here's another project where I did sort of a review, and they did quarterly releases. So every 3 months they release their system. they had 10 weeks of testing with a whole testing team. And again, they did 2 days of releasing over the weekend, which again is something that I would say isn't really that pleasant, because at the end of the day, that means that, well, you have to work during the weekend. And it's, as I said, an exciting experience and not a nice, exciting experience. So if you take, draw a graph of the time it takes to develop one of these iterations and to test it and then to release it, well, the goal that they had was to deploy several times a day. And that is why they brought me in and asked for some consulting. And deploying several times per day is actually a very good idea. So there is a book called Accelerate that I will talk about later on. And that book actually says that there is good evidence that deploying multiple times per day on demand is something that just doesn't just make sure that you can sleep during the night and that you don't have to work the weekend to deploy stuff, but it is also something that improves productivity and has a lot of other great benefits. And they asked me to how they could reach that goal. And I have to admit that the only way I can imagine how they could reach the goal, which makes a lot of sense, because it means they don't have to deploy during the weekend. It means that they will have a lot more productivity, that the only solution that I could think of was to go for microservices, because then you have testing, release, and development, and you can shorten the cycle because you have a much smaller system that you want to deploy. So you can have multiple systems and deploy them. And each of those deployments will be much smaller. And I think that's the only way how you can do that. Because if you look at the time scale here compared to this, if you don't convert that system from a deployment monolith to something smaller, I'm not sure how you can reach that speed up, because it's just such a huge speed up that I think you have to say goodbye to your deployment monolith and go for microservices. So I'm not sure. If people tell me that deployment monoliths are easy to handle, that they are much simpler and that they look magnificent, I'm not sure that whether we are talking about the same type of monolith. Because at the end of the day, the experience that I have with Monolith isn't always pleasant, but there are some cases, I would say, where deployment monoliths are actually really a bad idea and much too large. Now, having said that, of course, you can also come up with examples of architectures that are based on microservices and that don't really look that pleasant after all. This is also something that I'm going to talk about tomorrow. So tomorrow I'll be giving a presentation about modularization. And one of the examples that I'm talking about here, but I will also talk about tomorrow, is Netflix. And there is a video that explains the Netflix architecture. And I took a screenshot. And the small dots here that you can't really see, those are the microservices. And then there are all the connections, and that looks like a huge mess. And I would argue that probably no one can possibly understand and run this. And actually, I spoke to Adrian Cockcroft, who was sort of the original head architect of the Netflix architecture. And he said that he doesn't think that there is anyone still around who actually understands that architecture. Well, okay, so let's take a look at a typical monolith. And one monolithic architecture that I can still remember is, so that's not a screenshot from that architecture, but it is a dependency graph that you could have in your monolith. And in that architecture, about 90% of the whole system was in a dependency cycle. And almost everything depended on a huge package with all the entities, with all the objects that were actually modeling some business objects. And in that project, there were meetings where the teams had to coordinate, and they had to say whether they were influenced by specific changes. And it turned out that every team was involved in every change. So basically, everything that you ever did with that system needed to be done by everyone. So it's basically a huge mess. And it was an expensive, huge mess. And it was something that by the time that I visited the project wasn't even close to a first release. So I would argue that the monolithic architecture also has drawbacks, and there are clear cases where there are huge challenges, as well as in the microservices space. And if you think about it, when someone comes to me and says, okay, we have 1,000 microservices and we lost control, like in the Netflix case, and they later on say, well, you know, and that is why microservices are a bad idea. Well, I don't know. If I would show you a class with 1,000 methods, would you say that object-oriented programming is a bad idea? And I would argue that's basically the same point. The point that you're making here is that you have 1,000 modules and that you lost control over them. And in a class with 1,000 methods, it's also 1,000 modules. It's just on a different granularity scale. So it's basically the same problem. And with the 1,000 methods, you would say, well, it's obviously stupid. This is not what OOP should be like. This is not what object-oriented programming should be like. But for some reasons, 1,000 microservices seem to be fine. So I would argue if you have too many modules and if you have that mess, it's because you have a problem with your modularization. And I would argue if you look at modularization, it's probably surprising to say that to see that I start with the organization as a module. But if you think about it, the IT landscape of an organization is split into multiple systems. Each of those systems is handled by one or more teams. Each of those teams works on some business functionality, let's call it a bounded context, as we would do with domain-driven design. And then we would have microservices if we are using microservices, or we might have a different type of modules. So for example, we are in a Java conference here, so we could also have Java JAS, some kind of coarse-grained thing module, and Java JAS, you know, could be the result of some Maven build process, for example. So that's a different way of modularization. And I would argue that you have to choose. So you can either go with microservices as a modularization on that level, or you can go with Java JAS. And if you have 1,000 of them, whether it's microservices or Java JAS, you did something wrong. And that's not because you're using microservices, but because there is something wrong. And you should probably try to come up with more coarse-grained modules like bounded context or maybe teams, and think about them and try to have an organization on that level, and then split the system in, I don't know, 10 teams that each take care of some bounded context. And then you have those microservices that are abstracted away to one bounded context. And then you have something that you can keep in your head. Obviously, no one can keep 1,000 microservices in their head. And then you have more fine-grained things like Java packages, classes, and methods. And as I said, a class with 1,000 methods would mean that you would need to create another class. And if you have 1,000 microservices, you should probably build something like bounded context or teams and hide that away. And I would further, in particular, this Netflix architecture seems to be something that people use as an example of an architecture that is really a bad architecture. And I have to admit that I kind of can relate to that, because the diagram that I've just shown you, it's really not a beautiful diagram, and it shows some complexity. So that's obvious. And it is one of the architectures that we can actually talk about, because Netflix as you've seen, does presentation about it. I'm sure that there are other architectures that are basically the same. However, talking about Netflix, so I checked and Netflix still works. If the DNS works, if the internet works, but basically it does work, and they actually still launch new features. So the architecture that they are using seems to be working in a way because the software is working and they are rolling out new features. So it seems to be sort of okay. So the question is, how could that possibly work? And I would believe that the reason why this works is because if you have some person that works on the software at Netflix, that person can possibly only understand a very small part of the Netflix architecture. Only that small part is something that one person could really understand. And that means that we are probably seeing a victory of information hiding here, because the only way how a human can build software in this environment is by limiting the knowledge that is required. So there is no way to understand everything. So we have to have limited knowledge. And that is actually the only way to ever build complex software for us as humans. Hardly any of the projects that I see are projects that one human can understand or build. It is always a team effort. So you have to split the knowledge and you have to have some way to make sure that one individual just has to understand one part of the software. So maybe the successful modularization is the explanation why Netflix is still able to roll out new features. And actually, they are quite successful. If you think about it, Netflix has basically a digital business model. So all they do is send out some data over the internet. So software is very, very important to them. And they don't have their own data centers. They run on the Amazon cloud. And they are hugely successful. So they were founded in 1997, originally as a service that sends DVDs around. And the revenue nowadays is about $25 billion in 2020. I compared it to SAP because I'm from Germany and SAP is the biggest German software company that we have. And they are still smaller, but they are getting there. And they are worth more than Disney or SAP. And they are number 115 on the Fortune 500. So if you look at the Netflix architecture, you have to admit that Netflix is really, really successful, and they actually depend on the software. That is the asset that makes them successful in the marketplace. So I would argue that the Netflix architecture has achieved the ultimate goal that you can have, and that is business success. They are very successful. So they are doing something right. I'm not saying that we should all aim for this kind of architecture, but I think we have to admit that the architecture and the complex architecture that we see with Netflix is actually successful if you take, in my opinion, the only measure that you can take, which is business success, and they are successful. But you're not Netflix, so you should do something different. You should try to learn from their success. You should adapt it to your case. And I would not advocate using the very same architecture that Netflix is using. But I think what you should take away is that modularization is somehow key and that you should support your business and that you should work on that. The main point, however, that I'm trying to make here is that no matter whether you use microservices or a monolith, it is about modularization. So I can easily draw up a diagram that looks as ugly as Netflix with a deployment monolith, and actually I did it. And I have to admit that I personally have seen more projects where a monolith was just a complete nightmare than a microservices system. However, microservices are not the solution for that because it's just a different implementation for the same modularization. So if you mess up your modularization, then microservices won't help you. So you will have to fix your modularization. And that is why nowadays, me and quite a few of my colleagues are looking heavily into domain-driven design, because that seems to have some tools for dealing with coarse-grained modularization with monocontext and so on. So Netflix might be doing something right concerning software, because otherwise they would just be blown away by their competition. I mean, they are competing against Amazon, for example, which is not a pleasant company to compete against. And probably microservices are a great solution, at least for Netflix. So, and that is why I think this discussion is annoying, because it's not about microservices or monoliths. It's about how do you structure your system. That's the main problem. Having said that, there is another aspect of microservices that is often forgotten about. So if you have a microservice, you can have one or many instances of each microservice. So you split your system apart into different microservices. Each of them is a Docker container, for example. And now you can say, okay, I run 2 instances of this Docker container, and I run 10 instances of that Docker container. So you can scale them individually. You can have a different number of instances for each microservice. And I read an article not too long ago that actually stated that this is the real benefit of microservices. And if you have that requirement to scale parts of your system independently, it's hard for me to come up with any other solutions than the one that is called microservices. There are other benefits. So if you write a memory leak in your microservice, then that microservice will crash, not the complete system. The other microservices will continue working. They won't crash. They might be influenced by the crash of that one microservice, but at least they are still running. You can have firewalls between microservices. You can run the microservices in different environments, so in a demilitarized zone or in your high secure zone in your data center or whatever. And these are, so microservices have solutions for specific challenges that you might have, such as scaling parts of your application individually. And therefore, they are just another tool to solve specific problems. And in some cases, such as independent scaling, I'm not even sure what an alternative would be. And this religious debate that says, well, you must not use microservices because they are so very complex. Well, fine, but if you don't really have an alternative, you will probably stick with microservices because that's the way to go. And I would consider the trade-off. So obviously there is a trade-off. You have more complexity in for operations, for example, but it is something that it's like another tool that you have in your toolbox. And if you want to repair something, you won't always use a hammer, but if you have to use a hammer, it's quite handy to have one. And I think it's the same thing with microservices. If you really want to use microservices because they are a solution for that specific problem, then you should just go ahead and use them. However, this is something that is sort of forgotten in the microservices discussion, and the real reason why a lot of people are interested in microservices is more productivity, and somehow microservices should improve productivity. So we all know these stories that say, well, if you split your system apart into multiple microservices, you can have independent teams and they can just work on specific parts of your system without interfering with one another, and so on and so on. And that leads to the question, what does actually improve productivity? And I already mentioned this very nice book that is called Accelerate. And in that book, the authors talk a lot about some scientific studies that they did based on surveys. And therefore, they do have some, data to back up some hypotheses they have. And one of the chapters actually talks about architecture. In that chapter, it says, what is important is to be more productive. What is important to be productive is enabling team to make changes to their product or services without depending on other teams or systems. And of course, microservices might be an enabler for that, because if you split your system into 2 Docker containers or multiple Docker containers, then you can change those. You can have a new deployment. You can even change the technology that is used in that Docker container without talking to the other teams that take care of the other Docker containers. So microservices might be an enabler. The fun thing is that the discussion goes on and says, the discussion that we are having is often focused on tools and technologies. Should the organization adopt microservices? Should it adopt serverless, Kubernetes, Mesos? And what they say is that this is the wrong reason to focus on. So it's not about technologies or microservices for that matter. And I find that quite fascinating, because I, of course, having written a few books about microservices, I tend to think that they do make some sense, at least in some circumstances. But and therefore, I would think that they are an enabler. But they say the question whether we should use microservices is the wrong question, because these tools are irrelevant if people hate them, or they don't achieve the outcomes and don't enable the behaviors that we care about. And I can actually relate to that, because, again, a story from some consulting. So, as I said, microservices enable independent deployment, and you can have independent technology decisions. Each Docker container can have its own technology. So you could have one written in Java, and you could have another one with an application written in Rust, and so on and so on. And the client that I was talking about in that case said, well, we are doing microservices. And I guess they were doing microservices because they were aiming for these productivity improvements. But we deploy all of them at once, and the architect makes all the technology decisions. So even though microservices enable independent teams and enable independent decisions, they didn't use it, which leads to the question, why on earth are you even doing microservices? And there is an organizational problem here, because obviously the teams are not allowed to make use of the benefits they could have with microservices, and microservices won't fix your organization. And that's basically what the Accelerate books has too. So coming back to the life as an architect, I think often the question we should ask is why? Why are we doing something? And again, here's an example. So the example is, in this case, that the client does CQS. CQS is a way to split your system apart into a read and a write part, so to say, and you can scale both of them individually. So you can have one part that reads the data, the other one writes the data, and you can scale them independently. So if you have very different scaling requirements for those two parts, then you do have an advantage. So that sort of makes some sense. And later on, I asked the question, so what's your main challenge? What is the one problem that you need to solve to be successful? And the answer was, we must get users to accept our software. So you should make your software user-friendly. Yes. Okay, so what's the solution for that? They don't know. And I think this is quite funny in a way, because they don't have a plan to solve the problem that they really have, which is user-friendliness. However, they do have a plan to solve a problem, scaling, that they will only have if they solve the real problem, user-friendliness. Because if you have a system that hardly anyone uses because it's so user-unfriendly, well, you don't need to scale. So it was unclear how to achieve the user-friendliness. So it was unclear how to achieve that main goal. And scalability is only a problem after you actually solve that problem. So the real goals of that specific endeavor were basically wrong. And actually, they decided to skip CQS after I talked to them. And I think there is a huge problem here. And again, that is the reason why I think this is an annoying discussion. The essence of architecture to me is we need to identify the challenges that we have in the project. Then we need to make those challenges verifiable. So in this case, the challenge was user-friendliness. However, we can have a nice discussion about what is user-friendly. So for example, obviously, if you talk about editors, Emacs is the most user-friendly editor there is. And that's quite obvious, no need to verify it. And in particular, VI is obviously much worse. We have to have something to agree on whether we make the software really user-friendly, because otherwise we can't be sure that we actually achieve the goal that we are aiming at. And then we should have a solution for that. And then we should verify whether we made it to that point. We should verify that we reached that point. So let me go through that with the example that I've just given. So the challenge that we have is user acceptance. Okay, fine. How can we make that verifiable? Not a good idea for me to say this is obviously how software should work, because as I said, I am opinionated. So maybe one way to make it verifiable is to say the users award the application 4.5 or 5 points in the App Store, or over half the users would recommend the application. So we can agree that this is a measure for user friendliness. And what would the solution be? Well, if you ask me, I would hire a UX expert. And I would probably do usability tests and evaluate and do some evaluation by users. It's obviously easy to ask them, well, how would you rate that application on the App Store if you would rate it on the App Store? Or you could ask that person whether he or she would recommend it. Actually, I think they did hire a UX expert. And then we can verify. So we can take a look at the user reviews later on. And the verification is actually something that is often hard. So the verification that we're used to for performance, for example, we can verify whether we reach the goal for performance based on load scenarios. If you do a contact tracing app, for example, it's probably not that easy because there are people like the Chaos Computer Club that say, well, there are certain security requirements and you could fail to implement those security requirements and data privacy requirements, but maybe you are successful on a different level because you just get a lot of money because everybody's using that application nevertheless. So it is about the goals, and I spoke about that. If you look at Netflix, they are successful in a way because they are business-wise successful, and there are also contract tracing apps that are in a way successful because they make a ton of money, even though they might have some challenges concerning data privacy, for example. So, and again, this debate about whether we should use microservices or not is just something that I find annoying, because if I look at the projects that I see out there, the challenges are sometimes known. As I said, in this specific case, it is known that you should be user-friendly. That often that's not in writing. There is no document. So if I get some architecture document, it usually doesn't say, well, we have to have a user-friendly system. But the document rather starts with, hey, this is how we split our system apart, and it's going to be maintainable. While the real challenge, as I said, might be to have users even accept the system. Make the challenges verifiable. Usually that's non-existent. So I have yet to see an architecture document that says we are aiming for this kind of rating on the App Store or whatever, some kind of verifiable goals for user friendliness. And things like 10 milliseconds latency is also not enough, because you should probably break that down by functionality. It's a difference. There is a difference with when I click on a link and it takes 10 milliseconds for the next page to load. That's a different challenge from I searched that product database and there are 10 million products and the result should be on my screen in 10 milliseconds. So you should break it down per functionality, and there are functionalities where it is hard to achieve those goals, and there are probably functionalities where you don't really need that kind of response types. And then the solution, the example that I gave is typically a typical example, and that's actually quite sad because the solution that was chosen, CQS, doesn't have any clear relation to the challenge. And obviously, all of that is not visible in some architecture diagrams. So it is something that the typical architecture documentation doesn't even talk about. So I think this is really a problem because at the end of the day, users and customers will verify whether your solution works as desired. But that might be unpleasant because you might get out of business and you might have a huge failure and things like that. The point that I'm trying to make here is that there is no bad intention here. It is not about people who are willingly going to work every morning and say, okay, this is a nice day to mess up. It is something that we as an industry fail to really work on. And I would argue that people are trying. So they are trying to do their very best. And there are still issues. So we see that basically every day. It is just that people don't really know better or that organizations won't allow them to perform any better. So that is why I would argue that our role as software architects, IT professionals, whatever you want to call it, is to educate, support, and learn, and to make sure that we can improve. So I would argue that it doesn't make a lot of sense to get caught up in these almost religious debates, whether it's microservices or monolith. I don't care. There are specific challenges that I would rather solve with the deployment monolith. There are specific challenges that I would rather solve with the deployment with microservices. I might have a tendency to rather go for microservices because I've written some books, so I might be biased, but that's about it. And if some architect comes to me and says, this is the reason why we've chosen to do it with the monolith, and that's actually a solution for the problem that they're having, I think that's great. It's much better than someone who says, we are doing microservices because there is this book that you wrote and it has such a nice cover. And by the way, microservices is what is usually done these days, which is basically just no reasoning at all. So you should choose an architecture that fits your case that you have at the moment. You should understand and support business goals. That is, I think, the primary objective that we should have as architects. And we should educate, support, and learn with the other people around us, because at the end of the day, developers also make architecture decisions, and even we as architects, we can't push anything through. It can easily be ignored. So we do have to have, we do have to convince other people to follow the architecture, to follow the ideas that we have. And that means we have to support them with the challenges that they have. So the question, whether it's microservices or monolith, I don't really care. It is not, I have a bias, but it's rather something that I'm afraid of. It's not something that I'm really proud of. I rather want to have decisions that are somehow justifiable. And when I ask someone why they made that specific architecture decision, ideally, it should map down to some goal of the project. And of course, you will need to understand the business goals for that. And that is also what I'm trying to do. So oftentimes, the work that I do as an architect and as a consultant is to figure out what the business goals, what the business problems are, and then try to get some technical solutions for those problems. If you found the talk interesting, here's an email address. You will get a link to a Dropbox with the slides then. I will actually put that link also in the chat, so there is no need to actually send an email there. And on the Dropbox, there is also, let me just put out on the Dropbox, there's also, there will be the slides, so I still have to put them there. Some of my free brochures about service meshes, for example, about microservices and so on, some sample chapters from the books that I wrote. This is an Amazon Lambda system and a small microservice. So the data privacy note here is that your email address will be locked for 14 days. That's the shortest period of time that I can configure on Amazon Lambda. And if you write an email to the wrong email address, then I would handle it manually. So I will see your email address then. Otherwise, it's just on the log file, and I don't really look at the log files. So thanks a lot for listening. There was one question about whether the slides will be available. Yes, they will be. So, and the link to the Dropbox is in the chat. I'm happy to answer any other questions that you might have, and any other comments that you want to make. Silence. Back when there were conferences in person, there were people clapping their hands. And I have to admit that I somehow missed that. So nowadays it's just silence after the talk. And I totally see why, but it's still somewhat awkward. Clap, yeah. It was sort of, that wasn't really what I intended, but there is a question. Thanks for the great talk. Making challenges verifiable seems to be quite an important step. Is it comparable to writing acceptance criteria for user story on a big scale? That's actually a good question. So if you look at a user story, that's some kind of functionality. So you would have a functionality that says, okay, we are going to ship out some products, and this is how it should work, and this is how we are going to calculate how much money we are asking from the customer for the shipment. And if we ship this, this is how much money the customer will pay, and so on and so on. So there is some logic there. And if the acceptance test fails, in that case, it will mean that the rate for the shipment was miscalculated. What I'm talking about here is something different, and that is, if you stick to the example, how fast will the user see the result of that calculation, and how easy will it be for the user to understand it? How well is it presented? These kinds of things. How secure is it? These kinds of things. And those are, some call them non-functional requirements. I rather call them quality scenarios or quality attributes. And the reason why I was talking about this in this talk is because we are used to acceptance criteria for functionalities and for the correctness of domain logic, but we are not that much used to these quality scenarios and these kinds of things. And often, if you look at business analysts, they don't really care about it. So, and then it's left to us technical people, architects, to figure out what those requirements are. That is why I think they are important, and that is often overlooked, and that is why I keep talking about that. So it is comparable, but it's not the same thing, I would say. There is another question. Thanks for the presentation. What is your view on monoliths? That's a good point, and it is something that I didn't really talk about in the presentation. So nowadays, if you look at it, people. So I was talking about my experience with monoliths, and obviously that's a bad experience. And it seems that nowadays with the microservice discussion, people realized that modularization is a great thing. And now they come up with all kinds of fancy names for modularized monolith. And I think that's great because modularization is very important. So it's great that we now have that discussion about how to modularize monolith. However, how shall I put it? I would have wished that we had that discussion earlier, because then the monolith that I worked on back 15 years ago would probably have been more enjoyable. I think that's it. Not sure whether there are any other questions. Okay, so thanks a lot. Thanks a lot for listening. Thanks a lot for attending the talk and the questions and the discussion. And thanks a lot to Henning, who will do the next presentation, because we swapped slots, and that really helped me a lot. So thanks, and of course to the organizers and the conference for having me. So thanks a lot and have a great day. I'll stick around, so if there is anything, I'll be reachable for a few minutes on the chat, and I will upload the presentation in a minute.